an elaborate way of warding off attackers is a must, but some animals take it a step further. In today's video, the irony of expelling innards to stay alive, the most powerful punch in the animal kingdom, and the horned lizard's bloodshot eyes. But first, we'll start with this. Number 20. A hot chemical mixture. Turns out, we're not the only creature with the knowledge of explosives. If anything, we were a bit late to the party, by millions of years, beaten by a tiny insect called the bombardier beetle. Instead of bites or stings like the majority of insects, bombardier beetles have evolved a superpower of synthesizing and spraying a hot liquid from their rear ends. And just like any explosive going off, the spraying is accompanied by detonation sounds, which goes to show just how much work goes into this defense mechanism. Even more impressive is that the liquid isn't stored, but synthesized on demand by mixing hydrogen peroxide and hydroquinone from two different glands. The solution is then transported to a special chamber with enzymes that catalyze the reaction, giving rise to gases and, most importantly, a lot of heat. The next step is to fire, and the bombardier beetle has perfected this too. It's so good that it can fire off about 500 times per second, which is certainly more than enough to ward off threats. Scientists believe this special bomb evolved thanks to the bombardier beetle's wings. Tucked away in a shell, it takes the insect fairly long before it can take off in a case of danger, and that's where its knowledge of explosives comes in handy. Number 19. Swelling into a prickly ball. Being swift is certainly an important quality for evading predators, especially in the marine world. That's sadly something that the pufferfish seriously lacks. It's painfully slow, and its swimming is less than impressive, at least if we're talking about avoiding predators. But that doesn't mean they're an easy meal. On the contrary, most animals that know what's good for them avoid snacking on pufferfish as much as possible. Those that don't find out the hard way, although usually a bit late. Thanks to their highly elastic stomach, pufferfish can swallow large amounts of water and air, increasing their sizes severely. Ultimately, this makes them impossible to swallow, much to the disappointment of lurking predators. Even more disappointing for the dinner seekers is that pufferfish species have spikes, which, as you'd imagine, don't make for a tasty snack, not to mention dangerous. But even if the said predator is fast enough to quickly stuff down a pufferfish before it swells, chances are it won't live for long. Pufferfish skin contains a compound called tetrodotoxin, one of the most toxic substances known to man. According to National Geographic, tetrodotoxin is 1,200 times more poisonous than cyanide, and there's enough of it in a single pufferfish to kill 30 adult humans. Number 18. Extremely potent venom. The blue-ringed octopus is another extremely venomous marine animal, despite its unimpressive size compared to other octopus species. Averaging between 5 and 8 inches in diameter, it's not the smallest, but it's definitely far from being anywhere near big. But don't let that deceive you. Get too close, and you might end up in a rather watery grave. Hell, even the octopus itself is pretty keen on advertising its lethal nature with its yellow skin and brightly colored blue and black rings. When threatened, the rings become even brighter as the final warning to keep off. The bite is usually quick and painless, which makes it quite risky if you don't spot the little guy soon enough. And the effects kick in pretty fast, usually within minutes, marked by total body paralysis, where you're fully aware of your surroundings but you can't move or call for help. Although this effect fades after a few hours, it's definitely something you don't want in the middle of the water. And worst of all is that there's currently no antivenom. That doesn't mean certain death, but the chances of survival get smaller with every passing minute. Generally, surviving the first 24 hours of the ordeal indicates that you'll live to tell the tale. Number 17. Puking. Who knew? Other animals too understand just how off-putting vomit can be. This, as it turns out, is quite effective in staying alive in the wild. The Eurasian roller and the fulmar are especially known for this, though there's a slight variation on how each of these bird species goes about it. For the Eurasian roller, it's all about discouraging attacks. When frightened, the bird's chicks throw up, making themselves both unsightly and awfully smelly. Most would-be predators usually change their minds after that. The fulmar, on the other hand, doesn't cover itself in its own goop when threatened. In fact, it's not really goop per se, but more of a secretion, a foul-smelling secretion. But the smell, while off-putting, isn't the worst thing about a fulmar's mouth squirts. The fact that it's oily is what makes it so dreaded among avian predators. Any bird unfortunate to have to deal with the oil will most certainly die, since it causes matted feathers and generally interferes with waterproofing, consequently leading to drowning. Interestingly, fulmars also find themselves on the receiving end of their own weapon, but they don't usually suffer the same consequences as other birds. A bit of preening and washing out, and they're good to go. Number 16. Spitting venom. Snakes are some of the most famous venomous animals, even though most of them aren't even venomous. Of the 3,000 known species, just 600 have venom, and fewer than 200 of them pose any serious danger to humans. For the bad guys, they deliver their venom via a bite, which is pretty effective, as it can easily be transported to vital body organs once it gets into the system. That means the snakes don't have to be accurate with their strikes. The spitting cobra, though, has a whole other ballgame. While it can inject venom via a bite, its go-to modus operandi is, as the name suggests, spit. Actually, that's just a bit of misnomer, since it's not really spitting, but rather spraying. When faced with a likely attacker, the spitting cobra sprays out its venom by squeezing the muscles on the venom glands. This forces the venom out through a narrow tube in the fangs onto an angled surface and through a small hole in front of the fangs before hitting a target. For the most part, the venom is aimed at the eyes, since they're the most vulnerable to it. Number 15. Expelling sticky innards. Most sea cucumbers prefer hanging out on the ocean floor or just above it, sedentary for the most part, which makes them easy pickings for marine predators. Or does it? To avoid getting snapped up easily, they choose to sacrifice some of their guts, which are apparently disgusting enough that predators would rather stop their hunts altogether. Good for the predators, though, because the innards aren't just sticky and messy. They're also accompanied by a toxic, soap-like compound called holothrin that's fatal when ingested. The sea cucumbers, on their part, have to make do with the missing parts for up to 5 weeks before they regenerate, depending on the species. Number 14. Still on the subject of spilling guts, ribbon worms are another group of animals that use it as a last-ditch effort to escape from predators. The situation here is a bit different, though. Unlike the sea cucumbers, it's not really the intestines coming out, but a proboscis that the worms use for capturing prey, either by injecting paralyzing venom or by using thick, immobilizing mucus. Either way, the proboscis is usually pushed out by muscle contraction and retracted by hydrostatic pressure. But in the case of a predator, the retraction is completely eliminated. In a bid to get away, the ribbon worm will simply dump out its entire proboscis in the hopes of distracting the enemy. If it survives, the worm goes away without one of its most important parts, and since it can't regenerate severed body parts like a sea cucumber, its only hope is to last as long as its final meal can push it. Of course, it's not usually long enough, which kind of defeats the whole purpose of escaping in the first place, but I guess dying somewhere peacefully is far more attractive than getting snacked on. Number 13. Venomous harpoons. While land snails have the reputation of being docile and largely harmless, some of their aquatic counterparts can be extremely dangerous. The marine-dwelling cone snails, for instance, are some of the most fearsome creatures in the water, and it's not because they're physically intimidating. Much like their terrestrial relatives, they're slow, don't grow to imposing sizes, and move around with their shells for protection. In addition to that, though, they sting, excruciatingly painful and venomous stings. For this, a barbed harpoon-like tooth is always on standby in case there's prey or a predator in sight. In smaller cone snail species, the sting is nothing more than a bit of discomfort that goes away with time. But for the larger ones, like the geographic cone, the venom is worse and potentially fatal. Symptoms typically range from vomiting, intense localized pain, respiratory failure, and muscle paralysis. Deaths aren't that common, but this will depend on how soon first aid is administered. Scientists believe the paralyzing venom evolved due to the slow-moving nature of cone snails. A single sting is meant to completely immobilize prey, otherwise the snail won't have dinner. Number 12. Fibrous mucus. Yeah, mucus on food doesn't sound tasty at all, but it's not really the reason most marine predators avoid messing with the hagfish, the undisputed king of slime. Its other names, snot snake and slime eel, give you a rough idea of this creature's goo specialty. Instead of sharp teeth or venom, each hagfish has about 100 glands that seem to go into overdrive when the animal is either threatened or just stressed out. After secretion, the mucus rapidly expands as it mixes with water, so an extremely small amount could prove problematic to a predator in just a few minutes. This usually distracts the said predator as it has to choose to let go of the hagfish as it works out a way to unblock its gills. But with all the gooey water around it, this isn't usually successful, and most predators that find themselves in this situation end up suffocating to death. The hagfish themselves aren't spared either. Quite a few of them actually die from their own mucus, especially if they're not nifty in handling it. For the most part though, a hagfish can easily get out of the mess by simply tying its body in a knot and then sliding it from head to tail to clear off the mucus. Number 11. A powerful punch. The mantis shrimp is pretty small, growing to barely 4 inches long in most cases. For other animals, that means an easy meal against larger predators. But for mantis shrimps, nothing could be further from the truth. The tiny crustaceans can easily take on opponents several times larger than them thanks to their punches, which some scientists reckon are the most powerful in the animal kingdom. And it all comes down to a modified pair of club-shaped claws and their incredible speed despite the considerable drag in the water. Swinging at 50 miles an hour, the shrimp's punch is the fastest limb movement in the world, and you can bet they can deal some real damage. The average resultant force is about 1,500 newtons, equivalent to a falling 340-pound object. While the impact is devastating to opponents, the real problem isn't really the punches. The rapid movement of the claws lowers the pressure of the water immediately in front of them, creating vapor-filled bubbles. Once these pop, they produce an immense amount of energy that's enough to kill, or at the very least stun, most animals. Rock oysters, crabs, octopuses, and some large fish species are some of the aquatic creatures that have to deal with the immense powers of the mantis shrimp. Number 10. Cyanide. Otixia is a fascinating millipede genus primarily native to California. The millipedes here are known for their bioluminescence, an extremely rare characteristic in the larger millipede group. And just like in all bright-colored animals, it's a stern warning to potential predators. Like all the 3,500 millipede species in the Polydesmata order, they're covered in cyanide, one of the most dangerous substances any animal can ingest. The brighter the glow, the more the amount of cyanide that a particular millipede has. So, Otixia millipedes might seem like they're disadvantaged for being blind, but a predator ignoring that glow will have an awful experience. Generally though, most would-be predators get the memo as the millipedes have just a handful of predators in their native range despite their severe size disadvantage. Number 9. A poisonous skin. The golden dart frog comes in a variety of bright colors, namely mint green, orange, and yellow, from which it gets its name. To the human eye, it's attractive, but for most predators in the frog's Colombian native forests, the colors serve as a warning against attacks. And that's for a good reason. Despite the small size, the golden dart frog is considered one of the most, if not the most, poisonous animals on the planet. Most don't grow beyond 2 inches, but each one of them packs enough poison to kill up to 10 adult humans. As you'd imagine, very few animals can survive that much toxicity. Plus, the reward for the enormous risk is just not worth it given the size of the morsel, so adult golden dart frogs have almost zero natural enemies. As scientists have observed, the frogs synthesize most of the poison from their wild insect diet, probably a small beetle species that's been found to contain the same kind of toxin. Number 8. Toxic skin. The rough-skinned newt is another species with particularly toxic skin. Sure, this is the case with lots of other newt species, but our guy here is, let's just say, a bit extra with his defense potion, and it doesn't announce with the typical bright colors of extremely poisonous animals like the golden dart frog. But that doesn't mean it lets morsel hunters find out the hard way. The poison on the newt's skin is so potent that the newt has a strong, pungent smell that's a warning for any predator to not dig in. Still, it's preyed on by the garter snake that has seemingly developed enough resistance to the toxin over the past few millions of years. But even then, the snake has been observed to be remarkably slower after ingesting the toxin. As a workaround for getting eaten by the garter snake, these newts contain a special chemical that's released when they're digested. This is picked up by other live newts and tells them their precious toxin doesn't actually work on the snake, so they're better off avoiding a confrontation. Number 7. Fireball. Asian giant hornets are the ultimate villains of the insect world, not just for their size, but also for the ruthless nature of their attacks. For instance, fewer than 30 of them are enough to kill a hive of over 30,000 honeybees in a matter of hours. With their big mouthparts, one-on-one combat is a breeze for them, as they can move fast, decapitating several bees every few seconds. That's why the Japanese honeybees don't play around when it comes to hornet intruders. And they have a very ingenious way of ensuring they deal with just one at a time. When a hornet lands in the hive, Japanese honeybees usually surround him, forming a ball that prevents the hornet from calling for reinforcement. And then the party begins. Over the next few minutes, the bees vigorously vibrate their flight muscles, effectively raising the temperature inside the ball to about 115 degrees Fahrenheit. For the hornet, that's too much heat, which, on top of elevated CO2 levels, is the perfect combo to put it to sleep forever. Number 6. Mass attacks. Much like their Japanese counterparts, Africanized honeybees, also known as killer bees, are ruthless with the way they handle threats. In fact, they're so ruthless, they're not considered an ideal species for commercial bee farming, despite being bred to specifically produce more honey. Well, they are generally better honey producers, so at least that worked out. What researchers didn't anticipate, though, was the high aggression that would accompany the improved honey production. Unlike most honeybees, Africanized bees are generally more defensive, live in larger numbers, have a higher proportion of guard bees, and respond to perceived threats quicker. They also have a larger alarm zone around the hive, so they're more likely to attack a target that's not that close. And given the larger than normal number of guard bees, you can bet these attacks aren't exactly pretty. Of course, all bee attacks aren't pretty, but this is several times worse. In pursuing a threat, Africanized bees attack in larger numbers, which also means they sting a lot more on average, about 10 times more compared to the European honeybees, for instance. They also don't let go easily, chasing a target over distances of up to 400 meters. Number 5. Autothesis. Autothesis is a bit of a unique form of self-defense. Unlike the rest of the ways we've looked at so far, it means the death of both the attacker and the victim. It's about giving up individual life to ensure the survival of many others. It's a simple process, really. Common in certain species of ants and termites, it involves the bursting of an engorged gland that then releases a sticky or toxic secretion. The process varies a bit between the two, with termites using it to specifically block entry to their nest. The ants, on the other hand, use the technique in general battle to simultaneously kill as many attackers as possible. It's most useful against arthropods, as they're more likely to be affected by the small amount of sticky substance as opposed to a large vertebrate like, say, a lizard. That being said, it sometimes does work on large predators. As scientists have observed, some predators will avoid feeding on ant and termite colonies where autothesis has occurred, supposedly due to the secretions having a bad taste. Number 4. A gun. That's right, we're not the only ones in the animal kingdom familiar with guns. The aptly named pistol shrimp has one too, carrying it for as long as it lives. Granted, it varies in structure from a typical man-made gun, the mechanism and end results of using it are pretty much the same. The so-called gun is made of a single oversized claw that's always open. When a shrimp senses a potential meal or a predator around, it snaps it shut so fast that it creates a cavitation bubble that shoots off at speeds of up to 62 miles per hour. But it's not this speed that's actually dangerous. The real risk for any animal is when the bubble pops, generating temporary temperatures of up to 8,000 degrees Fahrenheit, nearly as hot as the sun's surface. Pretty much any animal would rather not have to deal with that. For those unfortunate enough to experience the resultant shockwave, instant death is almost always guaranteed. Aside from the unbelievably high temperatures, the popping of the cavity blood. Despite having a thing for raw meat, predators don't appreciate a sudden spray of blood, or at least that's what the short-horned lizard has demonstrated. A native of Central and North America, the intriguing species of lizard has quite the unique form of self-defense. If predators get too close, the little guy just straight out shoots blood from his eyes. To achieve this, the lizards restrict blood from leaving the head, which increases the pressure and eventually causes the small blood vessel around the eyelids to burst. The resultant jets are surprisingly strong, reaching a distance of up to 5 feet. Naturally, the sudden nature of the blood is startling to predators, which, of course, works out great for the lizard. Additionally, the blood is also foul-tasting, which convinces the predator to abandon the chase. It's quite effective, especially against canine and feline predators like coyotes, dogs, and wolves. For predatory birds, though, the foul-squirting ritual seems to come up short. Perhaps this is why shorthorn lizards apply other self-defense mechanisms like camouflage, puffing up themselves to appear larger, and running in short bursts and stopping abruptly to confuse the birds and other predators. Number 2. Poisonous ribs. Still on painful defense mechanisms, the Iberian ribbed newt also doesn't seem to mind a bit of physical discomfort. Endemic to the Iberian Peninsula and Morocco, it's the largest European newt species, averaging some 12 inches in the wild. Besides the size, it's also known for its unconventional defense of piercing its own skin. When threatened, the newt moves its ribs to an almost flat position while keeping its body perfectly still. The tips of the ribs eventually penetrate its skin, arming the amphibian with the perfect weapons against a would-be predator. The sharp pointed ends, though, aren't the only things predators have to worry about. As the newt begins its process of puncturing its own skin, it also simultaneously secretes poison from specialized glands in its body. This inevitably gets smeared onto the rib tips, making for deadlier weapons. Of course, the rib newt is itself injured in the process, so it might seem like a lot of work on its part. But as scientists have observed, the newts just go on with their lives unfazed. This is thanks to excellent immunity that prevents infection and collagen-coated ribs that ensure the skin grows back as soon. Number 1. Electric shock. Alessandro Volta gets all the credit for the modern electric battery, but the electric eel deserves just as much credit. The animal was basically a prototype since much of Volta's work was just copying its electric structure made up of about 6,000 specialized cells. Referred to as electrolytes, these cells are the eel's batteries that store electric charge for later use. When the current is needed, the electric eel's brain sends a signal to the electrolytes, triggering a sodium flow, which causes a sudden difference in electric potential. This generates a charge, enough to stun even the largest animal, like a horse. Usually, though, the exact amount generated will depend on what the electric eel is trying to accomplish. Lower discharges for detecting prey, and higher ones for actual prey or potential predator attacks. But on average, a full-grown electric eel can generate about 600 volts, which, let's just say, can be a bit of a nightmare to a lot of animals, including humans. But for the largest part, most people do just fine in encounters with an electric eel, as long as they can get out of the situation as soon as possible. If not, then multiple shocks have been known to cause heart and respiratory failure that inevitably lead to drowning.